Hey everybody, thank y'all for coming. I'm going to do a real short intro and then the real presenters are going to talk. So I want to say three things, just the format of this. So we really wanted to do sort of a showcase of stuff that's happening around campus by different people. So we actually have 4 different presentations and we only have an hour. So each presentation is going to get about 10 minutes, give or take. And I only say that because I don't want to discourage you from asking questions. So if you have a question in the moment, feel free to shout it out. But we are going to reserve about 15 minutes at the end for questions and discussion. So if it's something that could wait till the end, that would be helpful. That way we can make sure all 4 presentations get their full time. So that's the first thing. The second thing is we've got about like 40 people here today, but we've got, I don't know, Brittany, what do we have, like 10 people online or something like that? So for the people that are here with us, you won't hear the people online, but they'll hear you. So if you do have a question, use your teacher voice so that they can hear you from the back of the room. So Fatima, you got to really project back there. And then for the people online, if you have questions, just chat it. We're not listening for you, but we are watching. Brittany is on the chat, so she'll hear you. And we have a camera here. So that's that. The last thing is just about this. At some point today, go through these steps. We're doing this thing where we're experimenting with blockchain-based certificates and badges and things like that. So we'd like to give you a badge for coming today. It's real easy to do. Just go through those steps, and then we'll send you an email with some instructions. And those are called block certs. I'm not going to introduce all the speakers in the interest of time. I'm just going to say their names, mostly so they know what order to go in. Blair MacIntyre is going to be first. He's from Interactive Computing. David Joyner will be second. He's going to talk about OMSCS. Didier is going to be third, talk about from College of Engineering. And then we've got a crew from the Imagine Lab at College of Design. Miro, Noah, and Matt are going to be last. So without further ado, let's start with it's something.
Yeah, you just were muted.
Blue jeans. They didn't hear any of that. Oh well.
It was very sad for remote people.
Welcome, online people.
Do you want? How do you?
Oh
I
yeah.
don't want to touch. No touching.
No touch.
No touching. Okay. So I'm presenting from my phone for reasons that will be obvious. I was asked to just give a brief overview of XR. Why XR? What is XR? So that's what I'm going to do. So I'm Blair MacIntyre. I'm a professor in interactive computing. I've actually been on leave at Mozilla since 2016, and I'm currently this year on partial leave. So I'm partially here. It's good to be back in close. I think it's been like a year and a half since I crossed the bridge. Okay. And so I'm tethered to his computer, so I will try to stay out of the way of things. So what is XR? So I've been doing augmented reality stuff since I was a graduate student in '91, and there's this sort of word salad of terminology that you'll hear if you're in this sort of immersive space, VR, AR, and so on. So you might think of, augmented reality movies like Terminator. You might think of things like the First and 10 system for sports on TV. Everyone knows the lines fake, right? Sorry, I always have to make that joke. You might think of VR, video games, these sorts of things. Anything that's sort of immersive in 3D, and these different terms get used in different ways. Lots of science fiction's talking about these things. Different companies have co-opted the different terminology in different ways. So if you go back to old academic papers and read about augmented reality, people are really talking about full 3D stuff registered in the world. If you use Google Glass or look at something Google might have written, when they talk about augmented reality, they're talking about a small little screen on a heads-up display. It's not sort of one's better or one's worse. They're good for different things, but the word salad makes it hard to understand what a given study or a paper or something might do. So a lot of this stuff traces back to the 60s. This is Vince Foster, I think, is a student of Ivan Sutherland. This was like literally within a year of when I was born. So this is the first head-mounted display. It was see-through, was tracked by either ultrasonic sensors or by this long mechanical linkage. And it really was the first time that anybody could put 3D graphics out in the world. And nobody did anything with this technology or tried to do anything for many years afterwards because it was incredibly hard to do anything. Folks at NASA and Boeing in the 80s and early 90s started actually working with the concepts again. The terminology evolved after that, and people started doing lots of things. So you'll see in the educational and training spaces things for industrial stuff, medical stuff, teaching people how to repair cars or do other kinds of things. Lots of movement over into sort of more informal things. I've done a lot of work, so a lot of these are stuff we've done at Tech over the years on games and entertainment, but a lot of these things for sort of bleeding over into informal education kind of spaces, right? I think the big thing that I'm interested in and that a lot of people are interested in now is the potential for supporting collaboration and multiple people experiencing things. When you think about augmented reality, virtual reality, and related things, there's sort of an initial appeal of thinking about, oh, I could overlay a thing on a space to teach you, optical, or teach you fluid flow or physics or math. But if the experiences are solitary, you're limited in what you can do. So whether it's games or helping people remotely do things or supporting new forms of education, I think that's where I think a lot of the interesting promise is. So quickly, terminology. So virtual reality was kind of the first one. The term came from the idea of creating a virtual version of reality. The term augmented reality was coined by people at NASA and Boeing. I can never remember which one did it. Came up with it, I think it was the NASA Ames folks. Specifically in contrast to virtual reality. So the idea was we're going to augment real reality instead of creating a virtual one. Google at some point used that term for glass. Microsoft decided that they couldn't have HoloLens be augmented reality because augmented reality is a little heads-up display, so they called the HoloLens holographic reality, holograms, and so on, which irritated a lot of academics because they aren't really holograms, right? Magic Leap came along and decided that that stuff was just two-dimensional, so their stuff was mixed reality because it was going to mix things in the world. But if you go back and look at all the literature, mixed reality generally originally in the early work referred to sort of this spectrum of all these possible things, right? From virtual to augmented and so on. XR has been around as a term for a little while where people thought of it as cross reality or extended reality and so on. In sort of the non-academic world, is generally now used where X is like a variable. It's any of the realities, so augmented reality, virtual reality, and so on. To the extent that if you go and look at, say, Kronos, they're developing a standard called OpenXR, which is meant to provide a low-level device API to allow all of these different kinds of technologies to interoperate, right? So it's sort of equivalent to OpenGL or OpenSL or OpenAL or things like that. In the web world, we talk about WebXR for the same reason, combining all the different ways of creating 3D immersive experiences. So the X is not extended or cross, or it's just any of the above, okay? The reason this stuff's getting popular is the VR tech first started maturing. Then we started seeing a lot of AR displays. I brought a few if people want to look at them afterwards. I'm not going to want people to try them on because it gives me the heebie-jeebies to think about people sharing a display without cleaners and things, right? I have stories of pink eye and lice and all kinds of things, so we don't share displays. Which, as a tangential thing is a big issue if you want to start thinking about these in education. Fortunately, they're getting cheaper, okay? So, briefly, my work has been in augmented reality, thinking about creating stuff out in the world, right? So I just want to, I'll talk about two things that I think are interesting to contextualize this. So a lot of times when we think about augmented reality and virtual reality, we think about creating an experience that is meant to be an artifact to teach something, right? Or to help people learn something, whether it's math or something. I'm actually really interested in sort of stepping back and saying, how can we use these technologies to change pedagogy in a much more holistic way? Mark Gusdile, before he left, and Betsy DeSalvo and I did this experiment with CS1315 where we projected, we had projectors cover all the walls in a room. And the idea was, for every student in MediaCom, could they, when they ran a program to create a picture, it would automatically display on the wall. And the motivation was, could we start bringing in some of the sort of experience or pedagogical environment from design studios, architecture studios, where students can look around and see what each other are doing, independent of the fact that everything's hidden inside the screen in front of them, right? So much of what we do in engineering and even visual design and so on is hidden, so students in a room together may as well be somewhere else. Right here, we started seeing things where people would look at a picture and go, oh my God, how did you do that? Or, oh my God, you know, I had a problem like what you seem to be having, can I help you? Or your picture hasn't updated in a while, are you having problems? And it really did change the nature of the recitations. And so I'm actually really excited about that. The projection stuff was interesting. Eventually, you know, N years from now, when everybody could be wearing a display and I could look around and see your work floating above your head or on the table in front of you, we'll have more chances. Magnus Ergenstadt and the folks in engineering have been working on this thing called the Robotarium, which I assume most people are familiar with. And so we worked with him for a while to use AR to expose sort of the hidden state of robots, right, for multi-robot stuff. And Magnus could probably tell you more about the state of that right now. So those are the things we've done. As I mentioned, I've been at Mozilla for a few years working on bringing all this to the web, and I've been working on web-based XR, augmented reality, virtual reality, since about 2010. We had a series of projects here called Argon. And the idea, and the reason I'm excited about this, especially in the educational sense, is to allow us to take advantage of the characteristics that make the web useful, right? It's open, we can publish things on the fly, we can update things, people can bring their own devices, access stuff how they want, when they want. It's very easy to make multi-user experiences. There's no gateways, there's no sort of, I have to publish this thing through the app stores and so on. So there's a lot of advantage to the web, and I'd be happy to talk to people afterwards about this, especially when you start thinking about privacy and so on with these devices which have an inordinate number of sensors on them. Someone else is going to dig more into the idea of the metaverse, but a lot of us at Mozilla in particular and in the web world like to sort of touch on this idea of a lot of science fiction evokes this idea of the metaverse, of this big 3D world that we can go into. I think of it as this hybrid space where AR, VR are all part of this immersive environment. I might go into VR to do something, but I'm much more interested in these hybrid spaces where eventually people could be attending this, not watching video, but their avatars could be sitting amongst us, right? They might see us somewhere else, they might turn and talk to us, and we might hear them in our ears, asking a question, making a comment. When we can start doing these sort of things, it will sort of enable new kinds of experiences. And I think the web is the right metaphor and environment for creating these kinds of spaces, because we're not going to have one huge oasis like in Ready Player One. What we're going to have is a bunch of disconnected experiences. You could put one up, you could put one up. I can bounce between them. Some of them would be huge, like Second Life or High Fidelity, the new version. Some of them would be a single room, like David's doing with Hubs, and so on. But they're not, everybody is in control of what they want to do, and it has a kind of web-like characteristic. Okay, so briefly, random demo. So you can do the cool thing is you can start doing these things more on phones and things. So I'm actually running this in a web browser that I built at Mozilla, which has WebGL. It's based on ARKit. So that's a GLTF model being rendered in 3JS if you care about those sorts of things. You can do full graphics. It's interactive, so I can tap and put little people out in the world. And I like to show that random demo in the context of this because this is a presentation, right? It's a web program. This all sits on the web. It's running in the web. But I could mix sort of bland screenshots, images, text with interactive content in the context of a presentation. I actually have a version of this that I gave, which was networked, so everybody could go to the same URL, and we could see the thing together at the right time, right? And so I think there's a massive amount of things that we're going to be able to do very soon. And with the web, we can work on phones, VR devices, AR devices, and so on, and naturally have this. If you're interested in this, I can talk more about it here or later. WebXR, which is the basis for doing AR and VR on the web, is going through the standardization process right now and being implemented in browsers right now. I was actually messaging someone who's working on a browser on Magic.ly this morning as we're trying to get that stuff working. So you can't go and do it right now, but a year from now, we'll be able to deliver AR/VR experiences immersively on the web to every device, right? And so I think there's a lot of interesting things we'll be able to do in the very near future. Thank you. And if you want to see, so Magic.ly, touch it, look at it, still my phone. While David's setting up, this is a Lenovo display that I got. It's a Daydream-based thing. It's in the few hundreds of dollars, like 400, I think. Completely standalone, 6-DoF motion VR device based on Daydream. So these things are getting affordable and coming.
Cool. Thank you. So hi everyone, my name is David Joyner. I am the Associate Director for Student Experience in our online Masters of Science in Computer Science program. I do some other stuff as well. What I'm going to talk about today is, other side or? What I'm going to talk about today is what I call virtual reality for camaraderie at scale. If anyone thinks of a better term, feel free to let me know, because I've been searching for a term for camaraderie at scale for literally months, and my old term was smallness through bigness, which wasn't good, but if you think of a better term, let me know. But the dynamic I'm talking about is that traditional education, we have synchronous co-located classes, kind of like this, where we all agree to get together in the same place at the same time. And it's wonderful because we kind of build a camaraderie by the fact that you can see everyone sitting around. Even if we don't ask questions, even if no discussions happen, you just kind of see everyone peripherally taking place in the same, or taking part in the same experience. And you kind of look around and see if other people are confused, bored. You build some sense of community just by virtue of being together. But this environment is also inherently rather limiting in that we can only have people who can physically come to Atlanta and be here at this time. So this builds camaraderie, but it's also very kind of limiting in who can attend. And education has been built this way for a long time. Technology recently has come along to let us have asynchronous and distributed classes, which are wonderful because they appeal to the people who can't come here for class, can't be here at the right time. They can do things on their own time from wherever they are. And it's great. It lets us reach the audiences for whom the choice is not between online and on campus, but the choice is between online and nothing. So most of our audiences are people who have no other option to go to this kind of education. They can't uproot their families and bring them to Atlanta for 2 years. Tuition costs are high, but tuition costs even are more minor compared to the opportunity cost of taking time off work. So we reach a new audience, but I'd say no camaraderie. I'm not going to say there's no camaraderie. There is a lot of camaraderie in that environment, but it's a very different kind of sense of community. It has to be a little bit more deliberate. They have to kind of engage more proactively. It doesn't happen tacitly like it does in this room. And so many students report feeling somewhat more isolated, somewhat on their own in how they do this. But as we've scaled, something interesting kind of happens, which is, you think of, I'm working up a visualization of this, but if you think of kind of a calendar of hours during the day, we all have 168 hours per week. We estimate students for our online master's classes should spend about 10 to 15 hours a week on each class. You only need 3 or 4 dozen people before there's a very strong chance that whenever you're working on your class material, there are other people doing it as well. And as we scale up even larger, you will find that wherever you are in the world, there's more likely someone who is nearby who can work with you. And so what happens, or what we hope to have happen, is that as we get larger, we can reintroduce some of that camaraderie that you get from being in a room together right now, simply through scale. So the synchronicity part is taken care of. 168 hours a week, you only need a few dozen people to have that happen. Co-located, though, is more challenging. It does happen in places like New York and San Francisco, where a lot of students are gathered in an actual city kind of environment. But if you're kind of more out on the periphery, if you're not in a major city, you may not have access to that cohort unless we get extremely large. And even if so, there's something different about going to finding a shared place, finding a coffee house, finding a restaurant that will accommodate you, leaving your house, getting ready, going. If you're, as many of our students are, a parent with kids, taking care of childcare, or asking your spouse to take care of the kids while you go do this, there's a lot more overhead to physically leaving the house for something co-located. And so the question is, we can do synchronous via wherever you are, via your own computer. Can we do co-location? Students already use chat, and chat is great for this, but it doesn't bring the kind of empathy that we get from being in a room together. You could have 40 people all in a room together, all working on the content at the same time, and still no one really knows what the others are up to. There's no real transparency. You can do meetups, but again, those have the problems of actually being in a place that's high enough density that everyone's there, and then all the challenges of actually leaving the house to do it. And you can do video, and many of our students have formed these kind of ad hoc video study groups, which is really cool to see happen. It's also really hard to research, which is frustrating, but it's cool to hear that it's happened after it's happened when we can't look at it anymore. But students have also reflected that this is kind of, it's invasive. It's inviting people who are, at first at least, a little bit more than strangers into your home via camera. You worry about what's in the background. If what you like about online education is you can do it in your pajamas, you probably want to actually put real clothes on. So it's a little bit more invasive in that way. So the question is, can virtual reality supply an environment for this co-location as we get to these environments? So we use Mozilla Hubs through a grant from them. It's free and publicly available. It runs in the browser, so there's not the very heavy resource constraint of what you have. It has unique room URLs, so we can actually create different environments and just send out a link and say, here is the virtual reality room corresponding to this class for this reason. You can customize these rooms, so we can put decorations on the wall, we can control the physical layout of the room for different uses. And I think one of the most important things right now is it doesn't require a VR headset. You can attend with, I think, pretty much every VR headset is compatible, but it doesn't require it, because I find that VR, I think, has this kind of chicken and egg problem that to buy a VR headset, there may be a lot of good use cases for it, but for there to be a lot of good use cases for it, a lot of people need to have access to it. So it's kind of heads us off by saying that those of you who don't have it yet, you can still attend and participate. You won't get quite all the features that you would have if you were in virtual reality, but you can still actually participate. So we've been experimenting with that in my classes. We came up with five use cases. One is the simulated lecture hall, which is kind of like this, where people are all in a lecture hall together, watching right now a pre-taped lecture, although in theory we could do a live lecture in virtual reality as well. And kind of get that peripheral participation from your peers, see the fact that others are there, interrupt with questions, have it hosted, pause for discussion, discuss it after, discuss it before, kind of recreate some of that meeting in the hallway after class kind of thing, the emergent social things that are really hard to deliberately design for. I also thought about using this for office hours. I used to use video office hours in my classes and found that they were just really awkward because my video office hours were always 15 students showing up to listen to what I was talking to the other students about and no one actually having any questions. So it became 2 hours of y'all listening to me check email, which was just weird. But in virtual reality, there's kind of this more peripheral participation where I can be checking email, but I'm still in the room. You can come to the room, you can look around, you can see posters from my work on the wall, maybe see some papers I've written. You can interact with me via the room instead of necessarily being a one-on-one interaction. And in theory, it kind of replaces that effect we would have where if I have a professor whose work I'm interested in, I might just go hang out in their lab area and hear what's going on and participate kind of tacitly as opposed to really having a I want your full attention for 20 minutes kind of conversation. Lounge is very similar to that. So student lounge where students can kind of just pop into to discuss course material, unwind, to socialize a little bit. Fish bowls are one that I think could be very interesting as well, which would be discussions, panel groups, things like that, where you might have 4 or 5 students discussing project ideas, or experts kind of coming and visiting and things like that. And other students can listen in on that conversation, but still have it be in that kind of environment. And then poster sessions, I think, are one thing that we have recreated online in different ways, but we've recreated kind of the very mechanical aspect of them. There's all these PDF presentations, PDF posters. I can click through them, but I don't get that tacit interaction of seeing the other people wandering around, kind of overhearing that interesting conversation going on between those students over there, things like that. So we've tried out 2 of these. So we've tried out the virtual lecture hall. These are screenshots from what we did with this. Each of these little figures are someone who attended this virtual lecture. In the front, I think on the right, is the host of it who pauses and plays and might stop and ask for questions, things like that. We've done surveys of this. Our first one was a disaster. We found that the system didn't handle 45 people all trying to sign in at once, although that's an interesting issue of if it doesn't scale that well, but we know that the initial interest is going to be much higher, how do you manage that initial interest knowing that in 2 weeks it won't be an issue? But generally speaking, students reported they felt more connected to their classmates in this environment. They didn't feel that they learned more, and they mostly said they were going to go back and rewatch the lecture again. But I think most interestingly, almost all of them said that they would likely attend something like this again. So the feedback we get from students is they really see the potential of doing something like this. It's just a matter of kind of catching up with how we design the environments and how the technology works. We've also tried the social lounges a couple weeks ago. So I have 4 classes. Each one had a 2-hour social lounge where we just said, hey, this will be open for 2 hours. Pop by and interact with people. Did surveys on those as well. Interestingly, for both, we found that most students do attend via PC. Even students who had access to VR headsets chose to do it via the PC just because it lets them continue to multitask, everything like that. And interestingly, students in this one didn't report as much, so they felt more connected, and yet even more reported that they would likely do this again. So the same kind of thing. I think students have a sense of the potential of something like this and would like to see it evolve. So our general observations so far, one is that in that social lounge, there was a few anchors for conversation, so students didn't really have anything targeted to talk about. And we kind of figured that'd be an issue, but we also just kind of wanted to see what would happen if we just threw people in a room and checked what happens, since you only really get one chance to do that. Our next ones will actually have anchors, so the one we're doing next week is for our students in our HCI class, talk with an MSHCI student to find out the kind of difference between one class in HCI and a degree in HCI. We find a lot of interesting things around the social norms. People don't really know what the norms in virtual reality are. Do you actually approach someone? Do you just stay wherever you are and just treat kind of the teleconference thing? A lot of learning about that. Students initially will always experiment with all the different features, which is really distracting. So it really is a bunch of people in the room together experimenting with what they can do. But I believe that would go away if you have the same group of people doing it 3 or 4 times. They start to settle into something. So I'm curious to see what those norms will be. Like I said, most people attended non-VR. The VR attendees appear to have, they have some more function. They can do better writing. They have hands they can motion with, so they can do more things. But we believe we've observed that those people are less prone to use those features because there's something kind of awkward about me having a feature that everyone else doesn't have. I just kind of don't want to maybe show off or don't want to kind of engage in behavior that can't be mirrored. So one of our experiments we're planning is to actually get only people with VR headsets in a room together and see how that changes things. And most importantly, students are enthusiastic about what this could be in the future. The free text comments we've said is that this could really fill something that is currently missing in a lot of online programs. So that's all I have. If you want to read more, or email me, that's my address, and then my lab and others. So thank you.
While I'm getting Didier set up, can we do a quick sound check of online? Can they give a thumbs up in the chat that they're hearing it okay? Brittany?
I'm kind of feeling nervous, like I'm going to be crazy. I'm just kidding.
Oh. Sorry about your embedded policy.
No problem. I'm using the template.
Oh, okay. Well.
Okay. Hi, everyone. I'm Didier Contis. I'm an IT director for the College of Engineering. I'm a dreamer. And my goal today is to kind of talk about some of this large-scale, persistent, virtual shared space that we are going to need in order to support the kind of interaction that we've been talking so far, right? Quick note, some of what I'm going to talk about is seen from the perspective of one company in particular, magically, Blair as the ML1. It's one of many companies working in that field and are talking about this concept of this virtual shared destination. This company in particular has received a lot of attention recently, and are trying to create their own ecosystem. So Blair talked about VR, AR, MR, XR. Other companies are using the terms of spatial computing. For the purpose of this presentation, when we talk about MR or spatial computing, think about a digital experience where we respect the physical world, right? So, for example, in this slide, you have a robot, but the digital experience is aware of the furniture, and so the robot is actually capable to hide in a game behind basically the couch. So the term metaverse, right, has been around actually longer than we think. It's been introduced under the term cyberspace. The concept has been introduced as the term of cyberspace back in 1984 in the novel Neuromancer. Recent book have talked about it, using the term metaverse. Neil Stephenson in his book Snow Crash. Think about a metaverse, and I think Blair did a good job. It's just basically a virtual space, a virtual shared space, where you try to have the degree of convergence between virtual and digital. Well, let's try to define that a little bit better, right? Magically use the terms Magicverse for Metaverse and a spatial destination, computing destination. So how do you create a Metaverse? Well, let's take something which is large scale, like City of Atlanta. Now let's try to imagine what it could look like being fully 3D meshed and becoming a 3D digital destination. Okay? That needs to be persistent because over time we need to be able to have this kind of virtual shared space that can support long-term interactions. Like what David was saying, you want people to come and go, maybe leave objects and interact. It's not static, right? When you create this metaverse, this large-scale 3D mesh of a city, if you're going to have a building built on Spring Street, you want that building also to exist and being built semi-real time in the 3D digital twin representations, right? You also can imagine that you want to have the same conditions, whether it be energy consumption, traffic, weather being represented in the 3D representation. Where it becomes interesting when we think about now this 3D representation, digital twin of something like a city, is that now you can create thematic layers. Yes, we're going to have layers around transportation, we're going to have layers around energy consumptions, but you can create layers around specific things. So for example, we had this weekend the Super Bowl, so you can imagine that we could have created a layer around the digital twin of Atlanta specifically for the Super Bowl. And now you are, for example, in a bar in Buckhead wearing one of these augmented or MR headset, and you want to see, hey, how many fans of the Patriots or from the Rams do we have in this bar? Then you realize, hey, I want to go and visit basically the NFL experience. You get directions, you arrive at the NFL experience downtown. Now you don't know how to navigate. Your headset gives you specific information on how to navigate that experience. Super Bowl is over. What happened? Now you want to move to a different layer. It's a transportation layer because you want to have really precise information on how to go quickly to the airport because you want to get out of Atlanta. So this is like a high-level vision of how a metaverse can play. What does it mean for Georgia Tech? Well, let's imagine that at some point there will be a 3D representation of campus in one of these metaverses. Maybe it's a metaverse of Magic Leap, maybe it's a metaverse created by Apple, by Google, so on and so forth. How do we use it? Okay, one possibility is we're going to have multiple layers. Obvious layers to support research first. If you are a grad student, you want maybe to have some kind of interaction at the cybersecurity or energy research layer. Maybe you're going to have a layer around instructions. Some layers may be accessible only in specific locations because you need to have a high degree of interactivity. So maybe you're going to be in a specific location like the GT Atrium, which has more advanced apparatus to let you interact with equipment here, like high degree precision manipulators. So one I like to think about is what it could look like from the perspective of a freshman. Imagine, for 2019, you're a freshman. You're sitting trying to pick up a cup of coffee at Starbucks, and you're interested into makerspace. You jump into the layer of the Georgia Tech metaverse or one makerspace, and you want to find out where you can have laser cutters, interact with people. Hey, there is a laser cutter in the IDC of one layer. You go there. What happened? You want to use it. Well, you cannot. You have not received proper safety protocol on how to use a laser cutter. Now the virtual assistant on your headset that you're wearing tells you how to get a training. You get the training. You start to use it. Machine goes down. Another virtual assistant is helping you at that layer to guide you on how to do first level diagnostic while you're still wearing your headset. No external assistant required. Still not working. You can find out which of our laser cutter is now available. My goal here is to try to get you to think about how now we can imagine a 3D representation of Georgia Tech and layer on top of it multiple kind of layers. It's not going to be easy, because when you talk about a metaverse, when you talk about creating a digital twin of the Georgia Tech campus, you have to think about, this is not just about getting 3D representation of outside the buildings. You have to think about creating accurate 3D representation of inside space, this room. This is not about just the room itself, but the chairs, the tables. Some companies are working on this. 6D.ai is trying to think about how to crowdsource people using their phone, being able to take partial view of a room, and all of this being combined and creating this 3D representation. Centimeter or very accurate visual positioning is going to be tricky. Think about the kind of interactions that David was talking about. But now you want to have actually someone remote, someone in this room having some kind of interactions. If you put something on the table, you want that thing being also accurately represented in terms of location in the 3D space. We're also going to have an impact on this campus, right? I mean, we're going to need a lot more infrastructure to support this kind of digital twin, this kind of metaverse. You can think about the kind of network bandwidth, the kind of network infrastructures we're going to need in order to support this level of interactions. We're going to have a lot more sensors that we're going to need to think about. Imagine the concept of geofencing, right? Maybe if you have some rooms accessible in the digital representation of Georgia Tech that are only accessible if you are in a specific locations remotely. So maybe there will be some room like this one that you can only access from your MR headset only if you're in the GT atrium. And only if someone is physically here. We're going to have also to think about all the level of interactions. Today, we think about the visual interactions, but if you want to manipulate components in one of these metaverse, are you going to use your hands? Are you going to use voice? What about avatars, right? I mean, David, you introduced the concept of avatar. How many type of avatar are we going to support? Are we going to have official avatars if we are students? But if we want to interact at the makerspace layer, are we going to have more artistic avatars? What's going to be our policy at Georgia Tech? Over food for thought. How many digital twin of the Georgia Tech campus are we going to authorize? This concept of large-scale virtual shared space, there is multiple visions. There is a vision from Magic Leap. There is a WebXR vision. Facebook, Google, Apple are all going to have their own vision. How many digital twins are we going to authorize? Are they all going to be their own digital singletons, their own digital entities? How are we going to connect to them? You don't want to have isolation if you're coming from an Oculus Quest, coming from Facebook, or from an Apple device, or from a Magic Leap device. What kind of rules, policies are we going to need? Are we going to have different level of rules around the kind of interactive behavior we're going to have in Metaverse? What about accessibility? Thank you, Matt. 508 compliance. That one scares me really. And what about cybersecurity? That's a part that really interests me. How are we going to hack the Metaverse? So hopefully this was useful. Again, this is just one vision. Thank you, Blair. You could have done it.
All right. Brittany was texting me during the last presentation. Is the audio better? Okay.
Okay. All right. My name's Matt Swarts. I was in the Imagine Lab. Recently, I've moved over to GTRI in the Energy and Sustainability Lab. But because I have such a long history with the lab and I know about all of these projects, I'm going to present about these. But my colleagues here, Miro and Noah, right there, they run the lab right now. And we're just going to talk about, I think there's just 3 projects in here. One of them is about, actually I should explain what the Imagine Lab is. It's a lab that's primarily funded through activities around the campus and campus planning and operations. And since the Olympics, since '96, we've been charged with maintaining a model of the Georgia Tech campus but we often get requests from city governments to make similar kinds of things, and we merge them all together, and we have this large 3D model of the city of Atlanta that includes topography and all the buildings and the roads and all of those systems, and we maintain those and provide those to students in the College of Design or others who are on the campus for different research purposes for different segments of it. And then sometimes we use those for other projects as well, because content is king. You need the content that matches this the campus in order to do things that are necessarily about the campus, because that's a big hurdle, is creating that environment, even if it's a low resolution version of it, irregardless of high resolution. So here we have an application that we built where we, the question was about where to place a greenhouse on the campus. And so we flew some drones around, scanned the area, created a map, put it into the rest of our structure, added some trees where there's supposed to be trees, and creating this, giant fiducial marker that is a map, so that we can use that fiducial marker and augment it with additional information about the solar angle that other participants could look at, and then they could quickly see. Oh, and this piece right here is also another fiducial that represented the greenhouse itself, which you can see right here. And you could, people could move this piece around. Everyone who did not have a tablet could still participate in it because of the way the fiducials were designed. But if you had a tablet, and we had a couple different ones there, you could get additional information into it. So you always want to think about, when you're creating some of these environments, some people might not have tablets. If it's augmented or if it's VR, they might not have a device. So you'll see that as sort of a theme throughout these. Some other images of that. We could change the solar angle. We could also change some different characteristics of the trees. Again, this was a 1-week project, so it just had to be put out there very quickly. And then it was very easy for the stakeholders to come to a consensus about where they should put the greenhouse, which is now not in that location. Another project that we had was these tangible cubes. So we wanted to allow people to participate in the design process of city design or urban design. And we start off with Legos, but they're a little too small, and you'd have to build up a lot of them, and it also creates this idea that you need to be good at Legos in order to build something. So we designed these cubes that fit in the palm of a hand. A child or an older adult, they can still grasp them, move them around, and they have magnets attached inside, so they kind of lightly grip each other, and you can change the angles around with them. But we can also scan them in real time while people are moving them around. We can get the information about them, create a virtual twin of it, and run different simulations. If we were to consider this a building model, then we can run solar analysis, energy analysis, water demand. We can even run some expectations about how people are likely to interact in the space. And you can use this at different scales, at the building scale or at an urban scale. It depends on kind of the context that you want to use them in. And we explored some other ones later where we added some electronics inside it to make the scanning of it a little bit easier. And then here you also see a little bit of additional projection mapping onto the surface. The idea here is that when you require people to have a device, it makes it difficult for everyone to participate. So we try to make more interfaces that are more about tangible user interfaces. And this is an example of it where you're utilizing these tangible objects, scanning them, projecting back onto them, which leads to a similar project that we had here, which is a giant sandbox. Now UC Davis has an AR sandbox. It's primarily one projector on a sandbox. There's a couple that are a little bit larger, but we designed this one actually with 2 projectors and designed it actually so it can expand out even larger. But what it is it's really just a box of sand, a lot of sand. We've had to move it several times for different presentations. It's a lot of sand. And so it was actually designed so that we could, actually let me explain this. So this is just a bunch of sand. You can form it into different shapes. And in this particular case, this is for the Diane Fossey Fund in Rwanda to show 30 years of guerrilla movement data on the Virunga Mountains, which has a lot of elevation to it. So we built this, we designed this, built this, and shipped one to Rwanda, which is there now in their museum. And there were a couple things that we didn't expect or account for in the users. We thought that there would be about or about 10 people or so at a time that might visit this, and then they could use their phones to augment the interaction with it. So you could, select a person on here or select a group here, and then you could maybe do some AR or some VR and see something from the person's perspective. And then when we found out how the actual users is a little bit different, it ends up being that it's more like groups of 40 or 50 elementary and middle school students, and this is the first computer that they've ever seen. So they don't have phones. So we had to rethink. We continue to work on this and rethink how we use this to interact. But this is in their museum, and the museum's kind of a traditional museum. It's got a lot of Dan Fosse's artifacts, her table, her desk, and the kids, they told us, the kids are kind of like looking down, oh yeah, this is a museum, it's kind of boring. They hide this in the back, and then the kids get in here, and they said their eyes widen up, and they start to ask questions, not only about this, but then they ask questions about the things that they saw in the museum. To me, that means that's a huge success in what we've done here, and that this makes it very relatable, being tangible, being something physical that they can all share, not necessarily having a device on, is really great, and I think there's a lot of room for more development in this area. Another project that we had on the campus is ARboretum, the AR in it. And initially, we were trying to use some web tools, like Argon, and there were a couple others, but the use case really needed to be about people learning about the Arboretum itself. So there, on Georgia Tech's campus, we have over 12,000 trees. They are all mapped. If they're over 1 inch in diameter, there's a GIS layer that we maintain and gets updated with all of the locations of all the trees, and there are over 125 species, which allows us to get to a level 2 arboretum. And so what we did is we created, in addition to creating these traditional kind of arboretum tags, we also designed a solar-powered supercapacitor charging Bluetooth beacon that beacons out at each location of the trees, because GPS isn't enough to get you to the specific tree that you're trying to target with, and it works with an application, so it helps you guide you to that location, and then lets you know that you're in that spot, and you can sort of collect the tree as you move around through the campus. This is some more recent work that they've begun doing. Like Blair mentioned, the cost of the hardware is ridiculously cheap. In the 90s, these were $1 million to build a cave with so much additional support, and now $500. We should be buying these for every single classroom because it's dirt cheap. I don't know why we don't have them, but we should. This is an example in particular of well, there you can see the new stadium, but over here's our new building. Is this it?
Tech Square Phase 3.
Oh, Tech Square Phase 3. So this is actually where the parking lot is, just in front of Starbucks. But we do some projects with capital planning space management every so often where we're looking at projecting what the building space is going to be like, because we maintain the models, or at least some of the shells, some interiors, but the shells for them, so we can create animations or renderings or the VR or the AR experiences for them and modify them in real time so they can begin to ask and interrogate questions. So these kinds of VR is really helpful for any kinds of spatial programming like you have with city planning, architecture, and industrial design when you get to the product scale as well. Here's an example that is projection mapping. This was designed initially as like a Christmas card that you can open up, but we can also project onto the surface. Here's some other ones. These aren't videos, are they? No. Okay. So yeah, this was another one of the buildings, EBB, where you can project some of the information on, and this is one of the latest ones right now that Noah's working on, where you can scan this 3D. This is a 3D printed model of Tech Square. We have a much higher resolution of some buildings on campus. Tech Square is one of those, and there's a higher resolution model, and then some projection mapping that's being done with a single projector to highlight these edges, and then eventually do some other work on showing what might change with it. We also can integrate it and use this and the 3D object can be a marker as well, and you can augment additional information on top of this.
All right, so we had an email thread amongst the presenters and me about planning this, and we decided in that email thread that we were going to stick to 10 minutes per presentation, and I didn't believe anybody that y'all be able to do it, but they did it, so we have time for questions. So I'd just like to ask if anybody has any questions, or if you know of a project that wasn't highlighted today, we'd like to hear about those too. And I'm not going to answer any questions because I don't know answers.
Fix the presentation.
Oh, okay. I can do that. Did you have a question? Go
Just
for it.
wanted to see if we could get copies of any of this material available. These are great.
Oh, the slide decks?
Of the slide deck.
Is that all right with everybody? Yeah, Didier? Yeah, for sure. What we'll do is post those, post on the website, c21u.gotech.com.
So what's the status of manipulating objects? Are there haptics available? Are people doing the ability to manipulate material things? If you're going to do laboratory, for example, being able to push things around and stack them on top of each other would be exciting.
There's not much, right? I mean, the controllers that these Oculus and Vives and things have, the Knuckles type controllers, still are static things, which don't even have really haptic, like, they're not even as haptic feedback as like joysticks. So there hasn't been a ton of work on low-end haptics yet.
I've seen force sensing forceps, for example,
Yeah.
that will sense resistance, but I don't know if that's
Nothing mass-produced at this scale. I mean, I've seen research papers where people are still producing like chopsticks with little springs in them. So you can do that.
Companies working because there's so much energy going into that work right now, VR and MR, that are trying to research this haptic love, but like Blair says, it's prototype. Nothing cheap for students.
So actually, we in some of our user studies, we noticed that these controllers are, it's a great movement from the keyboard itself, but they're very awkward to use, and especially first-time user. They're ambidextrous, which is great, but when a person comes into VR, they're totally confused with these 20 buttons that they can press and which one does what. They also, even when you run a little tutorial to show them how, it's still awkward. You're holding something that does not correspond to the object inside of the 3D. For example, it looks more like a gun, but you might be actually working with like I don't know, some needles inside. Especially when you need some kind of a feedback from it. You're not getting it. Let's say you're training somebody that has to lift object that's 20 pounds, and you just lift it like it's nothing. So that can be a problem specifically in some training environments. So we do have some projects where we're trying to remove universal controllers and use haptic feedback, and then use some electronics like Arduino to prototype that and push it back into a game engine.
So yeah, it's definitely something you can prototype, but it's not, there's not really commercially available ones. They'd be a bit too expensive. And the degree to which you want to prototype can range in price. How realistic
It depends on a per case use. So something that's specific for you may not work for somebody else. Hence the universal controllers.
For the next 2 years, it's going to be 6 degree of freedom controllers, but I think people are also trying to look at, while you're not going to have any active feedback, more and more the headset are going to have, if you have your hand in front of your headset, you'll be able to manipulate, but again, the feedback.
So you do have, I've seen with like some of the Vive, Oculus, they have vibration feedback, which can provide at least some level of, I'm touching a thing and I feel it in the real world, which is better than you would normally expect.
If what you're trying to do is visual, is Wendy here? So Wendy kept mentioning during the CNE deliberations this idea of using XR to visualize complex systems. So you make, the educational application is you make this bridge, this XR bridge between a set of equations and some physical embodiment of a complex system. If you can make that dynamic in some way, that kind of opens up a whole range of subject matter that wouldn't be accessible otherwise. you can do bridges, I mean, you can do static things, I think, probably pretty well, but remove the truss and see what happens to the bridge is sort of a different ballgame.
So this is what you want to, I mean, I think, you know, you guys mentioned that you had the blocks, you know, you want to have, you know, using some kind of erector set, build a physical bridge on the table and try to use augmented reality to now start to project so that you try to predict what's going to be the failure, you try to experiment physically, and as you are, you know, experiment physically, you try to project vector forces immediately from all these methods.
Yeah, so we're trying to do a little bit of this in our labs. We were working a little bit with matching labs, hopefully we can do it in the future. And one of the ideas is we'll have something like a mass spring damper or a bridge or something like that, and students that are just looking at the device, whether it's static or dynamic, can't see where the forces are, the stresses are, the motion, what is the actual speeds that are coming from various sensors. And so we can collect that data into a microcontroller and then put that into an AR environment. And then while they're looking at and physically grabbing and moving around the physical piece, which kind of solves some of the haptic feedback issues, they can see what all of the actual force values are, what the data is that's being collected by the sensors. And that works decently well, although you have some lag issues that start cropping up.
There seems to be a heavy emphasis on visual in everything that we've seen today. And it seems to me that some of the real opportunity to create enhanced environments is to merge in auditory, thermal, or you name it, any of the other senses. But then to, for want of a better term, to zoom the scale that they're on, because we as humans are very limited. You know, we can only see in a certain range, and if we want to do better than that, we either have to get a microscope or a telescope, and we do, and then we see things that we can't see ourselves. Is there a move towards sort of trying to not just play in the same place that everyone else is, but to create even this richer, I'll call it a multi-sensor environment?
I mean, the best I can say is, you know, there is a trend seems to be that more and more headsets are trying to come and move from the visual to the visual and audio. I think, you know, a lot of the VR headsets are trying to come with integrated, basically, especially for VR, because if you have basically your visual obstructed and you do now the sound, then you can really start to create a fully immersive experience where you are much more removed from the physical world, right? So you want to explain. Even into like Magic Leap, they just partner with Sennheiser to try to also have that audio visual. But I think beyond audio visual, I think it's going to take a long time before you are able to go beyond that.
I mean, I think all of the experience, all of the displays have full spatial audio, and we'll do that. Just because, you know, the old joke about you turn off the sound of the movie and it changes, like all of the tension goes away. It's the same in these environments. We tend not to show the audio stuff because it's completely confusing if you're not inside it. Yeah, taste. People are experimenting with taste, sensation, smell. But it's just super hard again to do.
In our virtual classrooms, one of the nice features is that you can walk around, you know, with Matt and I having a conversation. We can go off in our own corner, and our audio, because we're closer together, is actually louder than people across the room. So hear them kind of at a distance. But I think it does bring up some interesting challenges around just kind of leveling and things like that. In video, I think it's a bit more objective. Whereas in audio, there's some questions about, you know, how do I know if someone's voice is louder versus their input is louder versus they're actually just talking louder. And it's different if I want to talk across the room to somebody. How does an interface figure out if we should continue to balance them out or project them because that's their intention? There's a lot actually more that goes into audio than video in those senses.
And just a more general question. There's an upcoming NSF mid-scale facilities initiative. Is there any group here on campus that might be pursuing something underneath that could give us a next generation test bed that a lot of these can. I know the individual headsets are cheap and so on and forth, but I'm talking about literally sort of the creation of an environment, immersive environment where we could do something like that.
The
By the way-
million-dollar facility you were talking about that we used to have 20 years ago. There was never one here, was there?
We had some Clarion and
Yeah,
I was at SFU and they had a facility.
yeah, many other universities had.
Yeah.
I don't think there was one here.
I would like to preface this by saying that I find this very interesting and cool. I came here wondering if I could implement something like this in my class in terms of student interaction and things like that. And I have to admit, as cool as this looks, I'm going, oh my God, that's a lot of work to set this up. And am I correct in that? And so like, at what time might it become reasonable for me to actually do this kind of stuff in class?
I'd say that at least for what I showed, you could do it right now. You go to hubzilla.org with one of their preset rooms. They create rooms for you. So if you're okay using one of the preset rooms, which actually our lecture hall is one of the preset rooms just because it worked perfectly for it, it generates a link for you. You send that link out to other people, and it just works. It's built to be very accessible. Getting it spun up was borderline trivial. Some of the customization right now is still like if you want to do a really specialized something. It's going to be more difficult. But I think the diminishing returns are pretty quick there. You can do a lot of work to get a little bit better, but most of what we've done has been with the way it works out of the box.
And it depends on what you mean, what you want to do, right? If you want to do the stuff like these guys described, where they're building custom things for educational experience, that starts to get harder.
I was thinking more in terms of what David's doing, in terms of the student interaction, see if I can enhance their discussions and stuff.
So is it as easy to do as Second Life or harder or?
I could never get Second Life running on my computer back on day, so it was easier than that for me at least.
Okay.
So,
And
Yeah.
tagging on to that question, I know you've done this a little bit in your class, but anybody else knows, how many of our students already have their own headsets? I know you asked that question, right?
yeah, we found about, in my online master's classes, we found about 8 to 10% already had access to one, and that was including things like cardboard or something like really low end ones. And 10 to 15% had them. So
I think one thing that could be really helpful for it is getting a 360 degree camera, and that would allow you to very easily record your class. It could be streamed live as well, but to post it just to YouTube would be the simplest way, and then people who have headsets can experience it in a three-dimensional view.
Yeah, there's some good workflow tools out there for doing streamed or at least posted 360 video with spatial audio as well.
One of the things, we were looking at that from the standpoint of some of our laboratories with the 360 video. One of the things I'll mention is it's very good if you want to have a single user in the environment able to look around in all the different directions. If you want to have multiple people that are able to interact with each other, it's much less powerful because unless you have multiple cameras all set up to where they can sit in different locations, they are unable to actually see each other. You know, one of the challenges, I really liked your question actually about how do you change somebody's perceptions and allow them to experience the world in a way that's deeper than what they actually can using their own senses. And that's something that we're very interested in because we're a mechanical engineering laboratory, and a lot of what the students are supposed to be experiencing is either happening too fast for them to see or is happening in the force domains or stress domains, which are not directly visible to somebody. And so there's a lot of ways of affecting either colors or affecting the sound that something has, or even allowing them, after they've collected their data, they can bring it into a VR environment and then we can slow down what they're experiencing. So something that's moving at 200 hertz, which is impossible for the eye to track, you can slow it down and see what the motion should look like.
So I don't know.
No, I had a different question. I was interested about the standardization process and like the WebXR and OpenXR. So exactly like what kind of parts of the augmented reality process are they trying to standardize? Are they trying to do like a common like SLAM algorithm for the computer vision stuff, or are they just building on top of all the different APIs? Or like is it standardization in terms of the content? Like will we have like some sort of hypertext content generation?
No, yes, no. The attempt is to build on top of the platform APIs and try to figure out a set of web APIs that will allow you to create experiences that can run in the browsers on any platforms. So there's no way you're going to, unless you had a completely open source, highly efficient on every platform algorithm for SLAM or tracking, it's not going to ever be part of a standard like that. And I think the platforms are advancing so fast that you couldn't. If you're interested in this stuff, you can go to github.com/immersive-web, which is where all of the discussions are happening. And the WebXR device API, which is the low-level thing, is the first step. But there's discussions about markup languages, about standards for all kinds of different aspects of what you would do to make web experiences using immersive tech. So it's just started. And there's a lot of different stuff going on. I'd be happy to chat with you offline. I don't know how much everybody's interested in W3C standards.
But at what point do you think we would have to think about, we would have to, some of the discussion about WebXR and aggregator about, all content. At what point do you think we would have to be serious about having like a much more standardized official presence, like a Gatech.edu, WebXR presence, or how it's going to look like from your perspective?
I mean, I would love to see us, with the stuff you guys are doing, we should be able, it would be entirely conceivable for us to have a presence on the website that anybody can visit in AR, VR, on the desktop, whatever, and take a virtual tour of campus by the fall. I mean, that would be easy for you guys to build, right?
Why would one go there?
Right.
What would they do? How would we do
That's
it?
why I explicitly said,
which way would we do it?
Yeah. I mean,
We can do it.
from a technology perspective, it will be over this coming school year, not this one, but next year, where all of the browsers on all of these devices are capable of delivering that experience. That is the question, is what is the experience that we want to deliver? I mean, I personally like the idea of the guided tours because students go to university web pages to learn about the university. And so you can imagine a lot of things that cater to that demographic. We've talked about that for years.
We've had some that were standalone you need to install where you can drive the rambling wreck around and you can move around with Buzz, fly around. But
and the reason I like the web for these things is that we already have a website, people are there, you can tap a button and get it, send a device, put on your headset or whatever. But I think these things are possible, will be possible to do within a year.
All right, well, thank you everybody for coming.
If anybody wants to